So hello everyone, this is lecture 6 for the classical physics, in which we were studying about the phase trajectories and all. So we ended that topic. Now from today we will start the central force. So first let's understand the meaning of central force. So what is that means? It means it's like take an example. You have Earth and our satellites and moon are rotating around it. Okay. So these are the example of central force. How can we say that? Means if you take the gravitational force between these two satellites and the earth, you will find out that it will be minus gmm over r square r cap. So see this magnitude of the force, it depends only on this r, the distance between these two objects. Okay, and it is along the direction of the line of force. Okay, so force is always in the direction of this position vector, means it is r cap. So this is actually the definition of central force, means force will always depends on the position between, means distance between those objects, and it will be along the line of force. Okay, so this is the definition. So you can see other example also, like we have this positive charge and we have negative charge. So the force between these, the Coulomb force, the magnitude will be like this: F equal to kq, and other charge is minus q divided by r square r cap. So this magnitude of this force, it depends only on the r, and the direction of force is along the r vector. So we call this also a central force. So these are some examples of central force, and central force is always conservative in nature. So what is the meaning of conservative? Conservative is when the mechanical energy in the process is constant, means it will always remain constant for a central force system, then we call that system as conservative. So central force system is always conservative in nature. The mechanical energy is constant, and mechanical energy contains kinetic energy and potential energy, you know that. So if force is in this form, when force is in this form, minus fr, this is magnitude, and r cap, so we call it as central force. And it's not necessary that it should be negative signs. Okay, it can be positive also. So like this, positive charge. So this force is also depends on the r, and it is along the direction of r. So we call this as central force system also. Okay, and it can be written in this form: F equal to fr r cap. So you can see these both are central force system: F equal to minus fr r cap or F equal to fr r cap. So hope central force is clear to you. Let's see the definition. The central force is a force whose line of action is always directed towards or away of fixed point, called the center or the origin of the force. Its magnitude depends only on the distance of the object from the center or source. So this is the basic definition. Okay, so direction is always towards or away the fixed point, called the center, and magnitude depends on the distance between the 2 points or the objects. Okay, so this is the basic definition. Now we will see some properties of the central force. If an object is moving under central force, then it will exhibit following properties. So what will be the properties? First, the torque acting on the particle moving under central force is always 0. So torque on the particle will always 0. How you can prove this? Torque is r cross f, this is position vector and this is force. Force is, we already given the expression, both expression is valid. So now this cross product of r and r will give you 0. So that's how you can prove that torque will be 0 in the central force system. Now second property is angular momentum of the body under the action of central force will always be conserved. So how can you prove that the momentum will constant? Means the angular momentum will conserve. How? Torque is nothing but rate of change of angular momentum, and it is 0. So from here we can see that L should be constant, only then this expression is valid. So angular momentum will be constant, and what will be the constant? Its magnitude is constant and its direction will be remain same. So these both points comes under this. Okay, magnitude will remain constant and direction will remain same. So let's understand this more. Third property is, if you take the product of r dot L, L is angular momentum, r is position vector, this will always be 0. How? Let's see. L is nothing but r cross p. Now r cross p will give you a vector which is perpendicular to r and p both. So r dot that vector will give you 0. So what is the significance of this? So it represents that if we have some angular momentum, then r will always remain the perpendicular to L. Okay, so let's say, and we already proved that angular momentum is constant and its direction is remain same. So if this is the direction of, this is coming out of the paper, it is constant. Now this r will always be 90 degree to it. So we'll see that the movement of this particle will be in a plane only and will always remain in this 2D plane. Okay, and this angle will be 90 degree and particle will always remain in this plane and move in this plane. Okay, so this is the significance of this r dot l. So it will always remain 0 and particle motion will always will be in a plane. All these particles will be in a plane which is perpendicular to l. And so you have this plane like this. This is the point, r is this, p is this, so r cross p will give you this l which is coming out of paper. So let's see the definition. It means particle is restricted to move in a plane which will be perpendicular to the l vector, which is constant. So particle will be restricted to move in this plane only. Okay, so this is a very important result which we will use. Now let's see the force property. Let's say this is xy plane and this is the plane in which the particle is moving. So if there is this particle and it is moving with v velocity, so any particle or anything moving in the 2D plane, we can represent the motion by the polar coordinates. Okay, in 2D. How? This r and theta can give anywhere the coordinates in terms of r and theta, like r cos theta, r sin theta. Okay, so if we see these polar coordinates, so this axis is r cap and this is theta cap. Both are perpendicular to each other, or we can say orthogonal. Now this v can be resolved in these two vectors, so it will be v theta and vr. Okay, so v can be written as vr r cap and v theta theta cap. So you will understand these polar coordinates more when we will discuss the vectors in the mathematical physics. Okay, so here just remember this, v can be resolved in these two components. Now angular momentum is r cross p and p is mv. From here, let's say it is r cross m, take m out, it will be r cross v, and now v divide this in its components, so vr r cap plus v theta theta cap. Now if we multiply r with r, it will give us 0, so we'll get multiply r within this inside, this term will be 0, so it will be m r cross v theta theta cap. So take the v theta out, and then r, and r is what? R is r multiply r cap. This is the magnitude of r and this is unit vector along the r, and we know r cross theta will give you z. R cross theta will give you vector in direction of this out of the paper, which will be z direction. So mr v theta, now r cross theta will give you z. So you have angular momentum like mr v theta z cap. Now v theta is nothing but r omega and omega is theta dot. So to understand this omega, this is theta d theta by dt. You have studied this in the 11th standard. So let me give you this example. Like we have this circular motion. So in circular motion we have not this radial component ever for the velocity. Why? Because this v theta is always perpendicular to this radial vector and whole velocity is along the tangent, and we call it v theta. So for circular motion vr is 0 and we have only this v theta, and v theta is r omega. Okay, but if we see in a elliptical path, so elliptical trajectory, so this is the two foci. Okay, now if particle is here and velocity is along this tangent, now it can be resolved in this vr direction and v theta direction. Now we have both the components. So that's how you can divide this. Means these examples are just to make you understand about the v theta and vr components. Okay, for different kind of trajectories and how it is r omega. So remember this, for the circular motion we have v theta equal to r omega, and v theta is r omega for each kind of any kind of trajectory. Okay, not just for this also. And vr is vr and v theta is r omega. This is called the angular velocity. So actually it is tangential velocity, this v theta, and omega is angular velocity. This is the relation between them. Okay, so we get the momentum as mr v theta z cap. Now if we substitute this v theta r theta dot here, we will get mr square theta dot z cap as angular momentum. Now if we take the magnitude of this, it will be mr square theta dot, and we call this magnitude as L, which will be constant. We already proved that it will be constant, so we represent it by L. So from here we can find this theta dot, it will be L upon mr square, and this is constant, you can see that, and it depends on the r only, otherwise it will be constant. So remember this result, the angular momentum. Now let's see the law of equal areas. You have heard about it in the Kepler's law, but it is valid for any kind of central system, means it will be valid in any kind of central system. And Kepler proved it for the planetary motion only, but it is valid in the all kind of central system. So let's see what is this law of equal areas. So area traced by the position vector in time dt will remain constant. Means in dt time, the area means the areal velocity is constant. Area per second will always remain constant. Okay, let's see how. Now particle is here, and in dt time it traverses this angle d theta. Now let's find the areal velocity. Area means area traversed per second. Let's see. So it is very small distance d theta, that's why we take this r as constant. It doesn't change. Okay, so it's like a triangle, and we can find the area as 1/2 base into height, and this curve can be find. This arc is nothing but r d theta. We know in the circle theta equal to L/r. From there L equal to r theta, so it will be r d theta. Now area will be 1/2 base r. Magnitude, we will take the magnitude only. 1/2 r multiply r d theta. This will give you 1/2 r square d theta. Okay, so this will be your area. Now to find the areal velocity, make it dA by dt. So you will get dA by dt as 1/2 r square d theta by dt. It is theta dot. Now theta dot you will substitute from here. Theta dot is L by mr square. Substitute here L by mr square. You will get L by 2m dA by dt. Now see, angular momentum is constant, mass is constant, so this dA by dt is constant. So that's how we can prove that areal velocity is constant. So area traversed by this position vector in unit time is called the areal velocity, that is dA by dt. Now what this means? It means the radius vector of the particle traces equal area in equal interval of time. It is called law of equal areas, also called Kepler's second law for planetary motion. However, it is a more general law and is applicable for every central force. Okay, so Kepler derived this law specifically for the planetary motion, but it is valid for all kind of central force system. Now in case of elliptical orbit of a planet, its velocity will be greater when it is close to the sun as compared to velocity when it is far away from the sun. So how can we verify this result? Means velocity will be greater here, lower here. How? Let's say area is same, but we will see that this path is less than this path. Okay, so in the same time, but we traverse this area in same time, so this will be slower here and it will be faster here, because in the last time we have to cover more distance, so speed should be fast here. So that's how you can verify. This can be verified by this areal velocity law. Okay, law of equal areas. Now we know area of this ellipse is pi AB, where A is semi major axis and B is semi minor axis. Let's say area is A, and the whole time to cover this whole path interval is t. So A upon t will be equal to L upon 2m. We know from this formula L upon 2m. So you can find this area as A equal to LT by 2m. So you know area is pi AB. So if question can be framed like this, means area will be given and you need to find something from this. So you can just compare these and find the values of AB or LT, whether it can be asked from anything. Okay, so just remember this formula, that this is area and area of ellipse is pi AB, and A is this, B is this. This is semi major axis, this is semi minor axis. Now let me make you understand. Now see this path. This is a path of an ellipse. Now if I ask you that at what points in the ellipse you will see that areal velocity component of the velocity will be 0. So there will be only 2 points, this A and B, where you have radial velocity component as 0. Okay, why? Because at this point this V theta component makes 90-degree angle, so there will be no radial component. So this component will be 0 here, this component will be 0 here. Just remember this point, that in an ellipse, only at the maximum distance from this center and the minimum distance from the center, this radial velocity component is 0. So this is kinda sun system. It is sun here and it is our earth. So for earth, the radial component will be 0 here and will be 0 here at the aphelion, at the perihelion. Okay, so remember this point, it is very important. Mostly questions are framed from this type of things. Okay, So this is the thing, and here it will be due to only theta. It will be theta here and v theta here. So if we take some point here also, so this will be our r cap direction, and say let's say velocity is in this direction. Now it can be resolved in two components, that is vr and v theta, and this is r theta. So that's how, but you can see both components are available in whole path, but here in this and this point this vr component is 0, and if we say that at this point this theta velocity is v1, and at this point this theta velocity is v theta velocity is v2, so we can compare the angular momentum means it will be constant throughout the path. So let's say this distance is r1 and this distance is r2, so m1 v1 r1 should be equal to mv2 r2 mv2 r2 for the same object. Now you can't write this expression for this any point here or here also, because here you should consider this vector form also, means both the components should be taken under the consideration, but here you have only one component and you have the same direction, so you can just equate them, okay, equate them. So from here you can find the information whatever you need, means radius or the you can find this distance. If one is given, second one is not given, and components are given, so you can just find any expression from here. Okay, so remember this, how you can resolve this velocity component into two components and how you can use this. Otherwise if you are taking just velocity, then it will be angular momentum will remain same in whole path, okay, mvr should be constant, but you have to take like mr cross p, okay, so that will be constant throughout the path. Now we have the sixth property. Central force can be written in this form, minus fr r cap. This is central force. Now central force is conservative in nature, so we know from this nature that del cross f should be 0. So and when it is conservative means mechanical energy is constant, and mechanical energy is sum of kinetic energy and potential energy, so it can be written in this form also. For the motion of particle under the influence of conservative force, the total mechanical energy will remain constant. So E will equal to T plus VR, that will be constant. Okay, here it is kinetic energy, it is potential energy, and it will remain constant because it is a conservative system. Sorry, I have to make this video fast because I have to go somewhere, it is urgent, but I will make it clear. So energy is equal to, now we know the velocity here is in the form of polar coordinates, so V equal to VR r cap plus V theta theta cap. So VR is nothing but r dot, you know in the polar coordinates we write velocity as r dot, and V theta is nothing but r omega, so it is r theta dot theta cap. Now if we find the magnitude of V, that will be under root r dot square and r square theta dot square, so the square of this whole will give us this half m V square, plus this is potential energy. So components are like this. Now distribute this inside, you will get half mr dot square plus half mr square theta dot square. So this component is kinetic energy due to radial motion, okay, and this is kinetic energy due to angular motion, okay. So you have two components, that's why you have two kinds of kinetic energy, and this is potential energy due to central force. Now in the central force we know del cross f is 0, so if this kind of thing is there, means del cross some vector is equal to 0, so this vector can be written in the form of gradient of some scalar. So here in the term when we are discussing about the force, so scalar will be potential, so f equal to minus del vr. So if you put this here, you will get del cross del equal to 0, so this satisfies this equation, that's why we can write this like this, okay. So from here you can see that f equal to nothing but minus del vr over dr. If it is a function of r only, it will be dvr over dr. So f can be found directly from the potential, dvr over dr will give you force in the direction of r cap. Now we know L equal to mr square theta dot, so from here theta dot is this. So we have this energy equation from here, total energy equation, equal to half mr dot square plus L square 2m square 2mr square plus LVR. So this is the angular momentum is constant, means put theta dot, this value of theta dot here in this equation, and you will get this L square divided by 2mr square. Now see here L is constant, because it is angular momentum, and it depends only on r. And we see that yes, it is kinetic energy, but we will see that it is depending on r only, and potential energy also depends on r only. So we can combine these two terms and make it as effective potential. Means for just our simplification of mathematics, it is not an actual thing, any effective potential. We are just making it for the simplification of maths. So the angular kinetic energy becomes independent of velocity square. Now it is a function of r only, means it is not a function of velocity, it is just depending on r, this second factor. So now it is a function of r only and behaves very similar to the potential Vr. So we combine these two terms, and we write these two terms as V effective R. Okay, now this V effective is this, so it is effective potential. Now you will see that now we are writing central force system as we discussed the things in the stability analysis, where we writing the energy as the kinetic energy and the potential energy. Okay, so it will be the sum of both of the components. So we already know how to solve this kind of equations and how to draw the potential curves, how to find the path trajectory and the phase trajectory. We all know about this kind of equations. Okay, so that's why we are taking the help of this combination, means we are combining these two terms and making in the form of in that form which we already know. Okay, now if we solve this for different kind of central force and or different kind of paths, so we will see that how we are getting elliptical path for the earth, and we are getting hyperbolic path, we are getting circular paths. Different kind of trajectory can be proven on the basis of what we already discussed, and we will use this thing here. Okay, and we always remember that here effective potential is just a mathematical term, and it is a sum of this angular kinetic energy and the real potential energy. And just remember this thing, that potential energy always come into picture when there is conservative system, otherwise there is no potential energy thing, and it is not constant. Okay, so this is only where the central force system we are talking about. So remember this type of equation we solved in the previous lectures. So it is something like this, because this is potential energy, kinetic energy, kinetic energy. So we can solve this kind of equation also like the way here. Okay, so in the space we are having different kind of potentials, so we can just substitute here and solve this equations. Okay, and find the path of the our planet or trajectory of any object. Okay, so the concept of effective potential allows us to convert 2D problem into a 1D problem. Now we are having this equation which is depending on r only. Okay, so that's how it makes us easy, it making for us easy to develop the theory or the practical things. Now in the next lecture we will see that how we apply this equation, and that will be very helpful. Okay, you can rewind this whole video and see things in a little slow. Okay, because I am just making this video very fast because I have to go somewhere. So we'll see in the next lecture. Thank you everyone.